Hello, this video is on direct variation, as shown here in the syllabus. Two quantities are directly proportional when one is a constant multiple of the other. If the quantities y and x are directly proportional, then we write y is proportional to x. This leads to the equation y equals kx, where k is a constant, called the constant of proportionality. We can also say that y varies directly with x, and the constant is also called the constant of variation. When y is graphed against x, the graph is a straight line which passes through the origin. We see that as x increases, y increases, and k is the gradient of the line. One pair of coordinates is needed to find the value of k. Substituting these coordinates into the equation will enable us to find k. In this example, the cost of a phone call varies directly with the length of the call, and a recent 5-minute call cost $1.60. A linear direct variation model for this situation is C is equal to KL. Substituting in the given values and solving for k gives k equals 0.32. So the relationship between cost and length of call is C equals 0.32 L. Once we have this relationship, we can find the cost of a 7-minute call, and that value is $2.24. Notice that the gradient k is, in this case, the call rate, 32 cents per minute. In this question, we're asked to find the value of t when p is equal to 60. If we start by stating the variation, we're told that p is directly proportional to t, so we write p equals kt. Then, if we substitute in the given values, which are 17 and 5, and rearrange the equation to find k, which is equal to 3.4. Next, state the equation, that p is equal to 3.4t. Now substitute in the new value of p and solve the equation to find t, as shown. So when p is equal to 60, t is equal to 17.6. If the quantities y and x to the power of n are directly proportional, then we write y is proportional to x to the power of n. This leads to the equation y equals k times x to the power of n, where k is the constant of proportionality. When y is graphed against x, the graph will pass through the origin. The non-linear direct variation model may be quadratic, cubic, or square root. Again, just one pair of coordinates is needed to find the value of k. Substituting these values into the equation and solving the equation for k will give the value of the constant. In this question, we're asked to find the value of y when x is equal to 4. We start by stating the variation, and since we're told that y is directly proportional to x cubed, then this leads to the equation y equals k times x cubed. Substituting in the given values, which are 34 and 2, and remembering to cube 2, and then rearranging the equation gives k equals 4.25. Alternatively, you can solve the equation for k on your calculator. From the main menu, select Equation, and then press F3, Solver. typing in the equation, so that's 34, and pressing Shift to get down to equals, using the X button to represent K, and then multiplying that by 2 to the power of 3. Press Execute to enter the equation. Note that the number next to X is not the solution to the equation, as we haven't pressed Solve yet. Press F6 to solve the equation. And we see that the value of X, which represents K, is 4.25, as we had before. Next, state the equation. That's y equals 4.25x cubed. Substitute in the new value, which is x equals 4. Simplify the expression to give the value shown. So y is equal to 272 when x is equal to 4. In part A of this question, we're asked to write an equation for d in terms of t. Start by stating the variation. We're told that the distance varies directly with the square of the time. This leads to the equation d equals k times t squared. Substitute in the given values, as shown, and rearrange the equation to find k, the constant of proportionality. Then state the equation. As k was equal to 1.5, the equation is d equals 1.5 t squared. In part B, to find the distance the rock has fallen after 5 seconds, substitute in the new value, which is t equals 5. Simplify the expression to give the value shown. So after 5 seconds, the rock has fallen 37.5 meters.